Okay, today's video is going to be still on section 11.1. This is part 2 for similar polygons. Today we're going to define similar polygons and investigate ways to show that two polygons are similar, and we're also going to apply similarity. So starting with the definition for similar polygons, two polygons are similar if and only if their corresponding angles are congruent and their corresponding sides are proportional. Okay, this word proportional is very important. We're going to talk about that soon, because we're not talking about the sides being equal. We're talking about making fractions out of the lengths of the sides, and that's what's going to be equal. So we'll discuss that more as we go through. Okay, so right here you see we have QUAD, similar. Notice the little symbol here, LITE. So this means quadrilateral quad is similar to quadrilateral light. And again, the symbol squiggle, or sometimes you see it in Spanish used, but I'll just call it a squiggle, means is similar to. So what we're going to do is a little practice with similar figures. So we're given that QUAD is similar to LITE. So we have two quadrilaterals. And what we talked about in the definition is that the corresponding angles are congruent. So what we want to do is make congruency statements for each of the pairs of congruent angles. So I've got angle Q congruent to angle L. At this point, if you want to pause the video and go ahead and fill these in, and then you can check as you go. And then we've got angle U is congruent to angle I, and then angle A is congruent to angle T, and angle D is congruent to angle E. So if you pause the video, let me fix that so you can see it. There we go. So if you did pause the video, how'd you do? Alright, next we want to talk about the corresponding sides being proportional. And again, we're not talking about the sides being equal, we're talking about making fractions. So the first pair of sides I want to look at are QU and LI. So if I take the ratio of QU to LI, that's going to be equal to the ratio of UA to IT, which is going to be equal to, so let's see, we did UA and IT, so now we're going to do AD, side AD, over side TE, which is also going to be equal to, the last pair of sides is DQ and EL. Alright, so keep in mind here that what we have is these are ratios of corresponding sides. And remember, when we talked about corresponding sides, those are the ones that match up with each other, and the ratios of the corresponding sides, and then we can see that they're all going to be equal to each other. Alright, moving on to the next page. This note here is very important. It says, in these ratios we are comparing the measures of a side of the larger quadrilateral to the corresponding measure of a side of the smaller quadrilateral. So keep in mind that we could have compared the measure of a side of the smaller quadrilateral to the corresponding measure of a side of the larger. So we could have done it the opposite direction. So order is important in these proportional relationships, so you want to make sure that if you have a side of the large quadrilateral or polygon or triangle, whatever you're working on, in the top, in the first ratio, that you also have a side of the large polygon or quadrilateral or triangle in the top for the second one. Okay, so we've talked about scale factor a little bit in class. I told you it was going to be important that we were going to use it. So it's the ratio of any two corresponding lengths in two similar geometric figures. So we're going to call that scale factor as just a ratio. So let's take a look at example 3 here. So we're given that QUAD is similar to FIVE, and part A we want to state the corresponding side pairs. So again, if you want to pause the video and see if you can fill these in, these are going to be your congruent ratios, and you may want to fill those in. So, and then I'm going to be using either the numbers or the variables for each side. So I'm going to start with DQ, so that's an 8. So 8, 2, and then the side that matches with DQ is EF, so that's X. So that's one of the ratios. So since I started large to small, I'm going to go large to small for all the others. So I'm going to go 6 to 3 for the next one. 6 to 3, then I'm going to go 9 to Z, and for the last one I have Y to 5. And I know that since these two quadrilaterals are similar, that all of these are going to be equal to each other. Alright, so if I wanted to write this as one long equality statement, I could write it as 9 over X is equal to 6 over 3, which is equal to 9 over Z, which is equal to Y over 5. And when I want to find these three variables, X, Y, and Z, really all I need to do is pick two of these ratios as a proportion and solve that for the missing variable. So if you notice, one of these ratios is different. It's the second one here because both of them are numbers. So that leads us to part B, state the scale factor from quadrilateral quad to quadrilateral 5. So that's the ratio of the large one to the small one. So our scale factor is 6 to 3, which is going to reduce down to 2 to 1. Alright, and we can use the scale factor, reduced or unreduced, however you like, to find X, Y, and Z. So to find X, I'm going to use this ratio. So I've got 8 to X, and that's going to be equal to our scale factor, so that's 2 to 1. So solving this, I'm just going to cross multiply, so I get 2x is equal to 8, divide both sides by 2, and I get x is equal to 4. Okay, next we'll solve for z. I've got 9 over z, that's going to also equal the scale factor, so that's 2 to 1. So again, cross multiply, I get 2z is equal to 9 times 1, which is 9, divide by 2. And I get z is equal to 4.5. Alright, and last we're going to find y. So here's my ratio with y in it. So I've got y is to 5. Again, we'll use our scale factor as 2 to 1. Cross multiply, and I get y is equal to 10. So I've got x is 4, z is 4.5, y is 10. Part D, we want to find the ratio of the perimeter of QUAD to FIVE. So the perimeter of QUAD is going to be 8 plus 6 plus 9 plus what I found for y, which is 10. The perimeter of FIVE is going to be, let's see, we have x, which was 4, plus 3 plus z, which I found out was 4.5. Let me slide that up so you can see it. And the last side was 5. Okay, so this turns out to be 33. And this, if we add it up, turns out to be 16.5. And if I want to do the ratio, so I've got the perimeter of QUAD to the perimeter of FIVE, it's going to be 33 to 16.5. And if we simplify that, we get 2 to 1. So what do you notice about the ratio of the perimeters as compared to the scale factor for the quadrilaterals in the beginning? So make yourself a little note there at the bottom of what you notice, and we'll talk about that in class tomorrow. Alright, moving on to example number 2. We're given that the two polygons are similar, so RECT is similar to ANGL. And we're also given that TR is to LA equals 4 to 3. So I usually like to write my proportions as fractions, so I'm going to rewrite this over here as TR to LA is equal to 4 to 3. So if I look at my picture, I've got TR over here and LA over here, so even though this is not 4 and this is not 3, they're going to be some multiples of 4 and 3. So we're going to let that be a 4x, and we're going to let that be a 3x. Alright, let's see what else we have. We have TC is 20, so I'm going to mark this on my picture as 20. And we also know that LA is 6 units, so this is 6. So we notice since LA is 3x and it's also 6, that these two have to be equal to each other. And I can go ahead and solve this for x, so 3x is equal to 6, divide both sides by 3, and I get that x is equal to 2. So now that I have that this is 2, I can come back over here and figure out that TR is 4 times 2, or 8. Alright, so we marked the given, we figured out some other stuff, and we can go ahead and answer parts A through D. We want to list all pair of congruent angles and write the statement of proportionality. So again, if you want to pause the video right now and see if you can fill that out on your own, and then you could start it again and see if you got it right. I'm going to go ahead and write these out. So I've got angle R is congruent to angle A. I've got angle E is congruent to angle N. Angle C is congruent to angle G. And angle T is congruent to angle L. Just a little recap, when figures are similar, their angles are congruent and their sides are proportional. So we'll go ahead and write the statement of proportionality now. So I've got RT is to, so RT and AL, so that's the ratio of that pair of sides, and we know it's going to be equal to RE to AN. Moving on to the third pair of sides, CE. So CE corresponds to GN, and that's going to be equal to TC, and the side that it corresponds to is LG. Okay, notice all the segments on the tops and the numerators are from the large rectangle, and all the segments in the denominator are from the small one. Alright, so we want to figure out the scale factor from rectangle ANGL to rectangle RECT. So now we want to go the smaller to the larger. Okay, and since I know that a pair of corresponding sides are LA and TR, that scale factor is going to come from those two sides, LA and TR. That's 6 to 8, which simplifies to 3 to 4. Alright, so here's my scale factor, and then I'm going to use this in part D to figure out LG. So I know that 3 to 4 is going to be the ratio of the sides of the small rectangle to the large rectangle. And let's see, LG, I want to find LG, and that's going to match with TC and the other one, so that's going to be 20. So I'm going to cross multiply. I get 4LG is equal to 60. 4LG equals 60. Divide both sides by 4, and I get LG is equal to 15. So we've got 15 over here. And now we want to find the ratio of the perimeter of rectangle RECT to rectangle ANGL. So what we found out in the other example is that the ratio of the perimeters for similar figures is the same as the scale factor.